In this section, we introduce logarithmic functions. And so if you haven't worked with those before, it's exciting and new, something different. And so we'll show you some information about that. All right. So say you have an exponential function. Now right here, this is an exponential function. And they want you to find the inverse. Well, we have a process for finding an inverse, right? So we learned that, in the last section. You replace f of x with y. You switch x and y. And then you're supposed to solve for y. Solve for y. And that becomes a problem because y is up in the exponent, and how are you going to get y by itself? So that's where we have an issue. And then that's why we have logarithms, okay? So that we can get y by itself, okay? We can get y down out of that exponent. All right, so there's a relationship between an exponential function and what we call a logarithmic function. And we'll show you that. And it's right here. Here's the relationship. If you have y equals a to the x, then log base a of y equals x. Okay? So they're both equations. This is an exponential equation. And this is a logarithmic equation. Logarithmic equation. Okay? Now, a little bit about the notation. The exponential equation, that we've worked with in the past, right? So we have the y, we have a base here of a, and then we have this exponent up here of x, all right? In a logarithmic equation, we have the abbreviation log, and we'll often say log. It just indicates that this is a function, okay? So it's like, we have notation for square root, right? The square root function has a radical. This notation then, to indicate that it's a logarithm, is you put log, okay? So we don't have like a fancy symbol, we just have those three letters. The log has to have a base. It's a subscript, and in this case the base is a. Notice that the base here is a on the exponential, and then over here it's also base a, okay? So log base a. And then you have to take the logarithm of something. It's like you couldn't put a square root symbol and just, have that mean anything. You have to have something underneath, right? You have to have a radicand. Okay, well, in this case, the logarithm, I'm going to put parentheses right here. You can. I don't have those in the original one, but you can put parentheses, and sometimes they're necessary. But this here that you're taking the logarithm of, you're taking it of, it's called the argument. In this case, it's y, but it's called the argument. So just like if you take the square root of 16, then that's the function. You're doing the square root function, and it's of 16. In this case over here, we're taking the logarithm of y, and it's in reference to base a. So it's log base a of y. And then that equals something. It equals x, which notice that's the exponent in the other equation. Okay? So y equals a to the x, and that means you can convert that to a logarithm equation, and it's log base a of y equals x. And you can go back the other way as well. So they can give you a logarithm equation and ask you to make an exponential equation. They can give you an exponential equation and ask you to make a logarithm equation. Okay? So there's a relationship there. I'm going to give you a quick little example. So let's say you have 5 equals a to the third. Okay? All right. then you could write that. If they say, hey, here's an exponential equation, we want you to write it as a logarithm equation, you're going to go log, you have to put log, and then the base in this case is going to be a. Then you're going to take it of the number that's on the other side, so it'd be of 5, and then it's going to equal the 3. Okay? So it's the exponent that it equals. You just have to get used to the notation. And in the next 2 videos, we're going to practice that. Okay? So going back up here, this is the stuff you want to remember. Okay? So put that like on a note card or something to help you remember that relationship.